Greetings, Hacksters! Welcome to our first Hackster Cafe of the new year. Our first guest is Jaydeep Dhrangdhariya, who is the founder of Bitmerse, which is the creator of Wiser, which is a new product that I'm very excited to hear more about. It basically enables you to, you can explain it more in a second, but my impression of it is that it is a pair of devices that you plug into your controlling device, whether that be your computer, and then a device that you're trying to control or speak to or read from or monitor, as though you were wiring them together with a physical cable so that they can chat over serial but wirelessly. How did I do?
Yes, I think it is almost perfect. Yeah. So, so you explained it perfectly. Let me just share a brief background about myself. So, I am Jaydeep, co-founder of Bitmerse LLP. We are engineering firm based out of Ahmedabad, India, and we offer services which includes embedded software development or firmware development, hardware design, as well as product engineering. And we are capable of providing also we are also able to provide support for small batch production. So these are the services that we provide. And yeah, today I think, yeah, you can just go to the services page. So
It's just taking a second. There we go.
yeah,
Very
all
cool.
the capabilities and capabilities are listed here, so you can go through it. Or then once then we can just switch over to the Wiser page.
Very excited to hear about that. Yeah, so how did you get started in this line of work?
Yeah, so I had done BTech in electronics and communication engineering. And then I started working as joined one of the company as a as a trainee engineer over there. And along the line, I then progressed through my career. And then at the last company, I was working as a project manager and multiple projects. And just about 2 years ago, we have started our own company with my partner, Drumil Doshi. And right now we are just working on few of the products that we along with the services as well. So we are developing few products that will be I think on sale in this year.
Cool. Yeah. Is there anything you can say about any other products that you're working on, or is this the first time that you're developing a consumer product?
uh, uh, Not actually, but yes, it is actually for the customers. We have built many of the products or projects, but this is our own product. So yes, we are launching our first product in the
Cool. This is
market.
the first one like you're releasing as Bitmerse.
Yeah.
Very cool.
Yes.
Well, let's jump in. Why don't you tell us a little bit more about Wiser?
Okay. So let me. I think I actually have additional camera setup. So let me
Oh yeah.
share share the screen. Uh, can you see the
It was
second?
there for a second. There we go.
Okay. So here we have devices, multiple devices. As you can see, this is the typical USB to TTL converter that we use in embedded development. It's uh, it's able to provide you the serial data on the host PC using the bridge IC that we have. Now the visor replaces this kind of uh, TTL to USB converter with a pair of devices. So on the so this module is called visor TTL, and this one is called visor USB. So similar to the USB to TTL converter, here we have, if you can see here,
Hmm.
the header pins are marked similar to the TTL converter. All the serial pins are available like RxD, TXD, RTS, CTS, DTR, and power supply pins. Along with that, we have LEDs here for TX and RX, which indicates incoming or outgoing connection from this module. And along with that, we have a connection LED here. I will explain it later once we uh, discuss the find pair button on the visor USB device. What is the use of this LED?
Hmm.
And along with that, we have connection for uh, power supply. You can supply 5 volt from here, or other option is to supply power from USB Type C connection here, uh, as you can see.
Yeah.
So here on Visor USBs, it is quite a small device where you just have TX and RX LED here, and there is a push button. If you can see, this is find pair button, which is the purpose of this button is to let's say if you are using multiple visor pairs in your setup, if you want to identify which USB is associated with which TTL device, then it you just need to press this button, and LED will glow it here. On the USB we have TX LED which will glow, and on visor TTL module we will have a separate LED, connection LED. It will also glow, so you will know that these two devices are paired to each other.
I think that's one of the
So
most, exciting things I was personally interested in about this, a very smart, included feature of these. So, if we look at the CrowdSupply, it's okay, is it okay to show this CrowdSupply page?
y-
It's public
yeah,
right
yeah,
now, so
sure.
okay, cool.
Yeah.
Uh, so folks, you can subscribe here to, subscribe to updates to see when Wiser is gonna launch, and if you scroll down on the page, you can see this, feature where it's got this find pair button to locate the paired device, which is what, of course, you were just demonstrating, and I saw that and I was like, "Oh, that's so smart!" So that you can have, like, multiple ones of these and always be sure, like, which one you're talking to exactly. Have you thought about integrating a buzzer that would do a similar thing?
Uh, we actually we can integrate it, but that would be like you can say overkill for this kind of
Makes
small
sense.
device. Yeah, so we just used LED for now.
Well, your lab mates will thank you for not including a buzzer. What else you got there? Are those
So
the internals?
yes, so along with let me just go through the cable also. So
Oh, sure.
this it will be having this custom cable
Mhm.
where on one end you just need to connect it to the TTL module, and on the other hand and you will have all the pins marked, so you just need to connect it to your target device. So this is how it will look like once it is in with the enclosure. Now this is the internal PCB of Visor TTL. uh, if you can see here, this is the main chip. It is ESP32S2 chip that we have used. uh, Here are the serial connection pins, and here is the power supply pins, and also the USB Type C connector. You can use either of uh, these two to supply the power.
Hmm.
uh, and here we have push button. This is to put the device into the boot mode in case you want to update the firmware. And on this corner we have RF chip antenna, which is used for the wireless communication. Now if you and on the back side we don't have any components. The reason why we have this design is because in case, so we along with this age, we also have castellated pins here. So
Mm,
in case you want to mount this TTL module on your custom PCB, you can do that, and you can supply the power from this two supply pins here on the edge. So that way you will be able to uh, communicate to your custom PCB using this module, and you just need to use the relevant Visor USB device on your host system.
cool. What's the range on these?
We have tested mainly we have tested outdoors and indoors, but I would say indoor environments are quite different.
Mm,
So for the outdoors, we have tested, and it is roughly around 20 meters that we were able to achieve between the these two devices. So and we tested the uh, roughly around 10 MB of data transfer between the TTL and USB module, and it's able to communicate bidirectionally with 10 MB of data. So roughly the range could we can say range is roughly around 20 meters in open area line of sight environment, and
nice.
it would vary in case we are in indoors, and if we have set of multiple walls or furniture in between, so it will vary. But the main thing I forgot to mention, yeah, so this both we have used ESP32S2 chip, which is having Wi-Fi 2.4 gigahertz Wi-Fi.
Mhm,
So the communication that we do between these two devices are on wireless Wi-Fi communication, but we are not using the typical Wi-Fi, but there is a custom protocol available from Espressif systems. Yeah, it is called ESP now. So we are utilizing that for communication between these two devices. So it is a custom protocol developed for to have a peer-to-peer communication in unicast or broadcast manner. In our case, we are just using it in the unicast manner.
cool.
So
I hadn't heard of this. This is awesome. It looks like it's especially low power as well.
yeah, and very low overhead as well compared to Wi-Fi.
Very cool. So, for those who may be joining us later via podcast, there is basically, I'm just going to describe really quick what we've got going on here. JDeep is showing off the two devices. So, there's the Wiser TTL module, which is the one that connects to the device, which is what would you say about like you've actually got a grid on there. Are those centimeter squares? It's about 4 by 4 centimeters. Uh,
Uh,
and then
yeah.
they're each a gray box with some like labeling on them. You've got a TTL cable coming out of the TTL module, a ribbon cable with a bunch of pins that are labeled, and then the Wiser USB module is about 4 centimeters across long, including the USB-C plug. Only 3 centimeters long without that, and about 2 wide. And then we've got the PCBs that go inside of each of those, and JD was mentioning that there's castellated pins on the TTL module so that you can mount it to whatever if you want to put it in your own device. And then there's also the standard sort of USB TTL converter on the left. So yeah, very cool. I'm noticing with these gray enclosures, I can't tell the ones on the screen right now, but in your CrowdSupply page, which I showed a second ago, they're
Yeah.
3D printed. And I'm wondering if you have plans to come up with another fabrication method for those before you release them on CrowdSupply, or if that'll be like a later development, or if there's plans for that already.
We have a plan for that, but right now we are just initially we are targeting to have a 3D printed enclosures. In later stage, if we have sufficient funding with the crowd supply, then we will we actually are communicating with the mold makers, so we have a quote ready for that, and if the budget allows us, we will go with the molded enclosure as well in the future.
Nice. And are you currently using a service to print these, or are you doing them all in-house?
We are using services. 3D printer is not available with us, so we are outsourcing that part.
Makes sense. Do you have a contractor that you would recommend? If you can tell me, you don't have
Um,
to tell me, but
it is quite so this is the local 3D printer services provider,
oh, it
which
makes sense.
provides service. Yeah, so it's not something that we outsource out of India. It is local service provider.
That's better in terms of carbon as well.
Yeah, yeah.
Love that. So let's see. When are you planning to launch this?
I think it should be launched. I can't commit the exact date right now, but it would be within a month, I would say right now. So I
Cool.
will I will urge all the viewers to uh, subscribe to the mailing list so that they get informed whenever the project gets launched.
Cool. And so that we're looking at sort of mid-February 2024, maybe mid to late
Yeah,
February. Awesome.
yeah.
Let's see. So your personal LinkedIn, I always take a look just to see what kind of stuff you've been up to in the past. And I was curious about how you have firmware development of smart wearable devices with Bluetooth technology. I'm always interested in what people are doing with wearables specifically. And I realized that you were on firmware, but are there any specific concerns that you have in terms of writing for wearables that differ from other types of devices? I can't imagine anything specific, but like maybe there's something.
Um, for the wearables, I would say the major concern for in the software one is, of course, the major portion is the battery performance, I would say,
Mm,
because on one hand you want to have all kinds of notification. Let's say you want to develop a smart watch or similar device, wearable device. On one hand you need all kind of notification, all the sensor data from the smartwatch to the phone, and along with that you also want to conserve the battery. So that is the main challenge when we say in terms of development for the wearable. So yes,
cool. I imagine there might be some privacy challenges as well since you're writing for
yes,
something that's going to
yes,
be on the body.
yeah, yeah. That is
How do,
also, yeah,
yeah,
yeah.
how does
Go
that
ahead.
come out in practice?
That depends on which. So the software stack itself, it depends on which software stack we use, which
Mm,
encryption that we use to hide out certain private information on the device, and there is also secure boot that you could utilize on the wireless on the device to prevent any kind of uh, data breach as well as hacking on the device.
mm.
So there are certain methods available to prevent that, but technology is advancing, so you always need to be in the catch up mode.
Oh, yeah. Speaking of which, how do you, these days, you're in the field, when you need to pick up new skills or just to stay current, how do you do that? Do you follow specific channels? Do you have specific places that you look when you're trying to pick up a new skill?
uh, yes, for that we just so I personally I'm subscribed to multiple YouTube channels like this, your channel as well, Hackster.io, and the other
Oh,
similar
yeah.
channels. So that way you know any of the new technologies that are introduced or in current trend or right now in trend, and that way you once you know that which are the technologies that will impact the or shape the future of the electronics industry or embedded systems, then you just need to go and read articles or relevant you can say research papers, or the relevant demos. There are also YouTubers which uh, showcase new let's say if your new board is just launched, they will explain all the details, so that way you just need to grasp all the uh, new technologies that are available in market.
Yeah. So I usually save this question for the end, but since it's coming up right now, what are there any specific technologies that you're tracking right now that you see as being new trends that are things for people to follow if they're interested in hardware? Like, what are you keeping your eye on as something that's upcoming and may change the field?
uh, I think one of the technology that I would say is risk 5 or risk v architecture. I think that may and it may impact the uh, available
Mm.
options that we have on the embedded. So we are also closely tracking that. And actually, I would like to share that initially we wanted to have ESP32C3 chip on these devices
Mm.
because it is risk based. Uh,
Oh.
uh, but there were a few limitations on that SoC, so we have to scrap that idea. Otherwise, it will this device would have a ESP32C3 chip.
Are you able to share any of those restrictions that prevented you from using the C3?
Yeah, sure. So on C3, so let me share how the this the Visor USB device works. So whenever you plug in into the your host system, you do not need to install any additional driver or software on the host system. The reason is that we are emulating a USB virtual serial port on this device. So whenever you plug it into the host PC, it will act as a virtual serial port on your device. The
Mm.
driver itself is available on all the modern operating systems like Windows, Linux, Mac, and Android. So you do not need to install anything on that. Now coming to the C3, what we had found out was so this device is emulating USB CDC class, which provides details on how the events needs to be transferred from host system to
Mm.
the actual device. So let's say on the host system, if you have changed the baud rate of uh, if you have changed baud rate to 115200, then that baud rate needs to be communicated to the device. But in case of C3, these specific set of events were not available, that were not
Ah.
communicated to the device. So we were not able to we were not be able to get the interrupts whenever there is a change in the baud rate or stop
Mm.
bits or parity. So that was the limitation on the C3. So then we just switched to ESP-S2, which uh, uh, which actually does run. So it there is also a difference between S2 and C3 architecture, where C3 has a virtual serial port as a hardware peripheral. So it is actual hardware peripheral inside the chip, whereas here it is a USB device, but you still need to run the software stack to emulate it as a serial port. So
Mm.
on S2 we need to run the software stack, and that way it is acting as a virtual serial port.
Awesome. Thank you for walking me through that. That's really interesting. I'm always
Yeah, but
interested in
on
like the choices like this that are made. Please go on.
yeah, so on S2, we are using Tiny USB as a software stack for the USB, and that way we are able to get all the interrupts. Like whenever we change the baud rate settings or change the parity bit or stop bit, that way we get all the interrupts, and the whatever change that we receive on this USB device, that will be further communicated to the TTL module. So let's say if you have changed the baud rate, it will get this TTL module will get notified, and it will change the baud rate here on the hardware serial port. So
Awesome. I wanted to show people you have, published a bunch of stuff on your GitHub, and you also have some placeholders for future, content on there, so let's just take a quick peek at that. So if you go to github.com/bitmerse/wiser, this link is gonna be in the description below. You can find everything that's currently up there. There's a Git book for documentation, and you've got a nice table of contents and everything, love that, and, not everything is already up here yet, but I'm assuming
yeah.
that, like, by the time you launch, it will be a little bit more built out. But there
Yes.
is
So along with the CrowdSupply launch, we are going to launch the source code and hardware design files. Everything will be available open source with open source license, so you can use it or modify it in whichever way you want.
awesome. I'm just writing down some notes here for later. But yeah, we can see that there's already a whole getting started page here that's in the GitHub, and
Yeah.
I think there's also this is also published elsewhere on your, is it in here?
You can go to the
There we
main website, our product website on bitmerse.com.
go. Great. Yeah, there we go.
There is,
Specific Wiser page. And all that good stuff. So yeah, look at this cute little box. I'm really curious about the whole process of getting a product out the door for you. What were some of your greatest challenges here? I know that it's not just you in the company, but you're working with other people. And so I'm not sure exactly what you were responsible for versus other people, but I'm curious about how you like went about, for example, developing your packaging and things like that, the kinds of choices that you had to make.
yeah, so typically this is the there are very few instances where we need to discuss or decide upon the packaging, because on most of the cases we just if we are working on some customers project, we typically supply the PCBs, pack them on a box, and then ship it without worrying about the packaging, the product packaging or anything. But in this case, we need to care about the packaging as well as the labeling and everything, and how it will be. So how what will be the ship, how we will going to ship it, how we will pack them, and all kind of stuff comes along with it.
Yeah, I've never brought a product to market myself, but I imagine there's so much that goes into that. Um, when you're building out, of course, it has to be more reliable than just your prototypes. Are there any kinds
Yeah.
of like hardening measures that you've taken to make it more rugged, more durable?
Yes, so there are few instances where we could encounter failure in sending the data. So we had make sure the we had make sure that retransmission occurs, as well as for each of the transmission of data, we have a acknowledgement available, and also the retransmission and retries available. So we are uh, trying to get all the data possible from one end to other, and without losing data.
Legit.
So and along with that, we have just ran regression testing on the devices to make sure that it performs well under every kind of conditions.
Cool. So here we've got the Wiser product manual on Gitbook pulled up here, and I'm just sort of scrolling through it to see what we've got. And we've got the device overview, we've got the sort of breakdown of what's on each one and how to use them right out of the box. It's already looking very good, so this at least will be, looks ready for launch day, honestly. And then we got the setup guide, all this good stuff. And this also will be in the description to the video. So let's see. You mentioned you had maybe a couple of demos. Is there something else that you were going to show?
Yeah, sure. Yeah, so I have two demos. One will be the live demo, and other one
Cool.
is pre-recorded. So let me change the camera.
I love that you have this all set up already. Like I can just sit back. I don't have to do anything.
Yeah. So this is a Visor USB device. Let me change the camera. Yeah. Okay.
I'm usually like
So
flipping back and forth between cameras and stuff, but you got it. There we
okay.
go.
So here we have Visor USB device. It is connected to my PC using USB extension cable, and on the other side, the TTL uh, is connected to a Raspberry Pi. Uh, the Raspberry Pi
Oh.
header pins are connected to serial port of the Raspberry Pi, and the TTL is power is supplied through USB Type C cable through a adapter. Now, the purpose of this demo is to access the serial port of the Raspberry Pi using Visor device. So, in typical setup, you would use a USB to TTL converter, but in this case, we are using Visor. So, we are trying to access the serial port remotely using Visor devices. So now let
Mm.
me share my screen here.
Haha,
Uh,
infinity mode.
so we can use any of the serial terminal software available on Windows or the operating system that you are using. Right now, I am using Teratom. Uh, you can also use Putty, or let's say if you are running any if you are you can also use Visor devices with script or custom application as well.
Hmm.
He, Here we have COM port. If you can see in device manager, there is one. Whenever you connect the Visor USB device, it will appear as a serial device on your PC. And here we have selected COM9. This is the baud rate for the Raspberry Pi 115200 and the other settings. Now, bear in mind that on Raspberry Pi, the uh, serial uh, port is not enabled by default, so all the serial logs won't appear. You won't be able to access the serial console directly. You need to have some configuration settings on the Raspberry Pi in order to use the serial port, but there are a bunch of tutorials available online, so you can just follow that for uh, to enable the serial port on Raspberry Pi.
Yeah, I think you can do that in Raspberry. Like you run raspi-config when you boot it up, and then you have that among lots of other options, like enabling remote
Yeah,
control over SSH. You can do camera enabling and stuff like that. So you're just logging in here.
yes, I'm
Cool.
logging to the Raspberry Pi. So this way we are able to access the serial port of the Raspberry Pi. We can run a bunch of commands here. Mm,
For those on audio, we're just doing some standard Linux commands, finding the present working directory, showing a list
Yeah,
of the current contents in the directory and stuff like that.
yeah. Let me just run kernel d message, so it will print bunch of messages at the terminal. So you
Nice.
can see it can handle.
Ah, wow.
So it's
So yeah,
able to
JDP.
handle bunch of data.
Yeah. Huh, that was really fast too. So Jaydeep has just been running a bunch of commands showing basically. So you've got the Raspberry Pi with the uh, Wiser TTL plugged into it over the using the 40-pin GPIO header. It's also plugged into that's power over USB-C, right? That the
Yes,
Wiser TTL, yeah.
T model.
Cool. And then there's also the Wiser USB module, which is plugged into your computer here, which is how the computer and the Raspberry Pi are talking over serial, just as though it were plugged in directly rather than going over wireless. And it is a very fast response. Whenever you type in there, it comes back very quickly. So
Yeah,
good.
it will.
Extremely low lag. Uh,
Yeah.
awesome. That's a sweet demo.
Yeah, and I would also like to mention the maximum baud rate that TTL or the Wiser devices support. So it's at maximum it is supporting 921600 baud rate. On minimum we have tested 110, and in between them you can use any of the standard or custom baud rates as well.
Nice.
So
And you've
it
got
will.
this listed on the product page on CrowdSupply
Yeah,
here, so you can go check that if you
yeah.
need to. Also, there's a bunch of suggested applications listed here. So we've got obviously wireless programming and debugging of microcontrollers. Also, obviously things like single board computers like Pi here. Remote
Hmm.
control and monitoring of robotics, remote access to industrial equipment, wireless data logging and telemetry, remote controls of drones and RC vehicles. It's really like low lag. It's fast enough to handle all kinds of stuff like this, like controlling a drone over wireless. Like, wow. And you said it's
Yeah,
got like a 20-meter range outside, so that's pretty decent
yeah.
if you just
In
want
the line of sight, yes.
solid. So what
Absolutely.
about demo number 2? You say you have a recorded one as well?
Yeah. Uh, so this one. So let me just explain the setup here first. Uh, can you see it now?
Yep.
Okay. So here we have a Wiser USB device plugged into a MacBook, and the wireless Wiser TTL is connected to the ESP32 C3 development board. Now, if you notice, there are few differences here in the setup compared to Raspberry Pi. The power supply for the ESP32 board is supplied from Wiser TTL.
I
So
was wondering
because
about
there
that.
are, yeah, so there are power output pins which you can use to supply your kit or development board or PCB. And along with the serial pins TXD and RXD, we are also utilizing RTS and DTR pin on the Wiser TTL. Now the reason is that people familiar with the development of ESP, uh, they will know that these two pins are used to switch the chip into the boot mode, and after the programming is done, it is also being used to reset the chip. So we so the setup uh, will be able to uh, put the device into the boot mode, then load the firmware, and at the last it will also reset the chip to jump into the main application.
Awesome.
So let me just play the demo now. So here we are using example from available from Arduino IT. We are using LED blink example. And we are
Selecting the board.
selecting port. We are selecting the baud rate. Right now we are selecting maximum baud rate. And then the serial port on the MacBook. And then we are compiling and loading the firmware.
Which will always take a second here.
Yeah, so as you can see, it is loading. It is
Yeah.
putting it into the boot mode, loading the
Ah,
firmware, and then eventually
and
running the
we have
main
Blink.
application.
That's so
Yeah.
cool. Nice. So Timon asks, hey, what's up, by the way, Timon? Could the range be increased with an external antenna?
Uh, it could be, but on these devices, as you see, we don't have the UFL connection. Otherwise, it could be increased.
Is that something you'd be interested in adding in the future? I know that you're still working on
Yeah,
launching V1, but like, it seems like
yeah,
something that would be pretty popular.
yeah. We are trying to, but we are trying to have a new revision, or you can say new version after this one. So that will have an increased range, either through external antenna and other ways to use antenna with higher. Other way, other option is to use antenna with higher gain to increase the
Mm,
range.
cool. Any other updates that you have planned for V2?
Yeah, so for V2, we are so this one is targeted mainly for, you can say, R&D and development, but second version we are targeting it to for the industrial environment, and it might um, it might come with a metal enclosure and
Mm,
also external antenna uh, that will have an increased range. So yeah, we are in still in planning mode. So once this gets launched, then we will also have some updates regarding the second version.
awesome. So for developing the rest of this one and also V2 for developing, for marketing, for everything, obviously you're building out a team. Is there a next hire that you're looking at making?
uh, Pardon, can you
Is there
rephrase it?
do you have ideas for what the next person you would hire, what the next position would be that you would hire for?
Right now, yeah, so we are still in so we right now mostly we fill up the uh, positions based on the work that we do, that is services, and this
Right.
product related. Yeah, so the positions that we feel is based on the work, the main work that we have related to the services, but along with the time that we can get, spare time that we can get, there we utilize it to develop our own products. So yeah.
Makes sense. So, looking again at the CrowdSupply page here, do you have
Mhm.
a planned price point? Do you know what it's going to be?
Um, right now, I won't be able to share it because it's still not decided yet. So I would just request you to just join the mailing list for now.
All right, stay tuned, everybody. And just like a final question, what's your favorite part of the dev process? when you're putting together a new product, what's your favorite part of that?
I think the main process is on development board. It is easier to develop the software, but once you have the actual hardware, then you can of course prototype all the software on the development board, but then you will the main challenge as well as the main obstacle is the hardware bring up, I would say. And once you are able to bring up the hardware, then it is quite easier for the further development.
Makes sense. So that's probably a lot more fun. Especially just like having it in your hand seems like such a breakthrough
Yeah,
moment. Like
yeah,
it's surreal.
breakthrough. Yeah.
Super cool. Thanks. Well, we're coming to the end of our show here. Is there anything that you'd like to throw in there as just like an additional, obviously, we'll show all the links again, but is there anything that you'd like to throw in there before we wrap up?
No, I think we had covered pretty much everything.
Cool.
What was
Well, everyone, be sure to subscribe for more hardware in your feed, everybody. Let's take another quick look at those links. We've got the CrowdSupply page. These are all going to be in the description to the video or the podcast if you're listening. Uh, if you're saying what podcast, that is something that we are working on bringing up for you. So we have the GitHub here with all kinds of stuff. The official product page on bitmerse.com. There is the main Git book with the Wiser product manual and also the Wiser Quick Start Guide. I also pulled this up again, I guess. There's Jaydeep's LinkedIn. And then ESP Now I pulled up. This is a really interesting wireless communication protocol for quick responses and low power control. I did not know about this beforehand. Of course, RISC-V, we talked about a little bit. And I think that's about it for our links. I also pulled up the product page for the ESP32-C3, but this one runs on the S2, if I'm not wrong. I am not wrong.
it?
Okay. Thank you so much for joining us, both Jaydeep, you, and all of our audience members. Love getting your questions. Thanks, Timon, for throwing that in here. Love hearing where people are watching from. Kron, awesome to hear you say that. And yeah, everyone, thank you again for joining us. I hope you have an awesome rest of your day or night, whatever time it is for you. And hack on.
Thank you, Alex, for having me.